All right, folks. Um, I'm going to go over a document that I made specifically because I wanted to make sure that you could see, like, visually, how sort of simple that stoichiometry can be. It doesn't have to be um, like this huge, difficult thing to do. It's pretty straightforward. So, I called it MVP stoichiometry. You'll see in a minute why that is. And here are the steps that I've sort of identified as you go forward on this. So, my steps are: number one, when you read the problem, you identify what the problem is. What's the given and what's the wanted, right? So identify the given and the problem. That should be like right away. Sometimes when you're having difficulty with the problem, just getting the given down helps you get the problem started. Secondly, identify the units that the given is in. That has to be both in what type of like moles, or is it grams, or is it molecules, or is it formula units, or atoms, or is it liters? Like, what are we talking about to start off with? If you need to perform a conversion, you have to figure out what type of conversion you have to go to. So if I have to go from grams to moles, that's I got to realize I have to get to. So basically, you know that in order to do any of the stoichiometry, you have to get to moles. One way or another, you have to get to moles. So if that means you have to go from grams to moles, from atoms to moles, whatever you have to do, that's what you have to identify. This is what I have to do. Okay. So then once you do that procedure, then, or when you identify that and mark that in, then of course this is the central part of all of stoichiometry, right? You do the mole to mole conversion. You get that ratio from inside the formula, or the unit. You get that ratio of moles to moles from the equation. Okay. You don't have to like figure something out or do some conversion. It's straightforward from the equation. Yeah, you got to figure out, what do I want for units in the answer? So maybe I want the answer in liters, or maybe I want the answer in atoms or molecules. And so when I do that, then I have to do some other conversion. I've placed here all three. These are the only conversions we will ever do. The mass conversion is going to be, you got to find the molar mass. The volume is 22.4 liters for 1 mole of gas at STP, obviously. The parts, which we're gonna be talking about, atoms, molecules, or formula units. Those are really the only three that we have when we're talking about parts, but that's the main thing we're talking about there. Now, let's go down a little bit. I want to show you how this is going to work. I go pull this up. So molar mass, obviously, mass on the periodic table, or you add up the masses of all the atoms in a compound. That just depends on if it's a compound or if it's an atom. So here's one of my first like real gimmies for you, like a real shortcut. If you're beginning the problem and you're going towards moles, your factors will always look like this. So as you're going towards moles, they always will be the like 22.4 liters on the bottom, or it'll be grams on the bottom, or it'll be atoms on the bottom, something like that. That will always be on the bottom. The factor will always be on the bottom. After you go through the mole to mole ratio on the center and you're coming back out the other side, the factor will always be on the top. Okay. That's just a given. And when you lay out the dimensional analysis and you see using the rules that we've done in the past, you'll see this is absolutely true every single time. So I want to show you this example here using what we're talking about. So I'm going to go back to here. Whoops, I got to do that. All right. How many grams of hydrochloric acid do you need to end up with 25 grams of salt, NaCl, sodium chloride? So what is my given here? That's the first thing I'm going to do is identify my given. The only thing I'm given in this problem is 25 grams of salt. So I'm going to put 20. I want to get rid of that. Okay. 25 grams of NaCl. Okay. That's my given. Now I go, I have to get to moles, right? I'm not in moles right now. I have to go to moles. So I go over here. I have grams of NaCl on top here. Obviously, I'm going to have grams of NaCl on the bottom there. And I go, okay, how many grams of how many grams are there in 1 mole of NaCl? So I have to look up on the periodic table. I have one right behind me. I can look up what is the molar mass of NaCl. So I'm going to do this right now just to show you that I'm doing this with you. Sodium is 23. Chlorine is 35 and a half. So 23 plus 35 and a half, that is 58 and a half. So I'm going to write that in there. 58.5 grams of NaCl for 1 mole of NaCl. So at this point, I have moles of NaCl up here. So I'm going to put it down here. So I have it up there, going to go down here, NaCl. What am I looking for? I'm looking for hydrochloric acid. So I'm going to put the HCl on top, and I'm going to put moles of HCl. Now, this is going to come directly from the equation here. So 2 moles of HCl, 2, and in this case, it just so happens to be 2 moles of NaCl. Okay? Those are my mole-to-mole ratio from the equation there. Now, I go, all right, at this point, everything's canceled out, all the units except for moles of HCl, but I don't ask for moles of HCl. I need grams of HCl. So I go, all right, I need this in grams of HCl. So see how there's moles of HCl up on top right there? That moles of HCl is going to be down here, 1 mole of HCl. How much does 1 mole of HCl weigh? So this up here is going to be grams of HCl. Grams of HCl, so chlorine, we just checked chlorine. Chlorine's 35 and a half plus the 1 here, so it's 36.5. Okay? So now all we need to do, and I have a calculator right here. I didn't do this ahead of time. I have 25 grams times 1 times 2 times 36 and a half gives me 1,825 on top. On the bottom, I have 1 times 58 and a half times 2 times 1 again. So I have 117 on the bottom. So 1825 divided by 117 gives me about, I'm going to put it equal here, 15.6 grams of HCl. So it takes, in order for me to make 25 grams of salt, I'm going to need 15.6 grams of hydrochloric acid. So that is the basics of how you do stoichiometry. The other side of this page, let me show you quickly, has there's one additional problem there, two additional here. If you want to stop the video because you kind of got it, that's fine. In the meantime, I'm going to go through this problem right here. Hopefully, this ensures that those who didn't really get it the first time, that they get it here. So at this point, if you want to stop, you can. If you want to keep going, you can keep going. So let me go to this problem. How many grams of sugar do I need to create 110 grams of water? So my given 110 grams of water, right? 110 grams of H2O. What am I going to have on the bottom? Grams of H2O. What is the molar mass of H2O? That's what we need here, right? Molar mass of H2O is 16 plus 2, so we have 18 grams right there. My ratio, I'm going to have moles of H2O. I'm going to put the H2O up here so you see it. Okay, moles of H2O on the bottom. On the top, I'm going to have moles, and I'm just going to put shug for sugar. Okay, C6H12O6, that's sugar. 6 moles of water for 1 mole of sugar. Okay, so when you burn sugar, you produce when you burn 1 mole of sugar, you produce lots of water, 6 moles of water. So now I have everything turned into moles of sugar. I got to go out here. I go, how many grams of sugar? So when I convert it to grams, I'm going to have 1 mole of sugar on the bottom, grams of sugar on the top. How many grams are there in 1 mole of sugar? So this is going to be a little more. I have 6 times 12. So I have 72 plus 6 times 16. 96 plus 72 is 168 plus 12. So I have 180 grams of sugar up here like that. So now I just multiply across. On the top, I have 110 times 1 times 1 times 180. So I have 1,900 or 19,800. I'm sorry. On the bottom, I have 18 or 1 times 18 times 6 times 1 again. So on the bottom, I have 108. So 19,800 divided by 108, and I get 183.3. That's repeating, and that is grams of C6H12O6. Okay, that's how you do that one. Let's do one more. I'm going to pull this down. I'll do the last example with you just in case. So, all right. In this one, how many grams of sugar do I need to create 45 liters of CO2 gas? So that's the first time we're doing liters. So here we have 45 liters of CO2. Down here, we're going to have liters of CO2. Up here, we're going to have 1 mole of CO2. Conversion factor, very simple, 22.4 if we're at standard temperature and pressure. If it doesn't tell you, just assume that we are. Now I'm in moles of CO2. So I go, all right, so I'm going to have moles of CO2 on the bottom, moles of sugar again on the top, because we're up here wanting to do sugar. 1 mole of sugar is 6 moles of CO2. Now I'm in moles of sugar. I got to get to grams of sugar. So down here, 1 mole of sugar is how many grams of sugar? And I believe we just figured that out, correct? 180 grams of sugar. So back to here we go. And we are at 180 grams of sugar. So now we multiply across. 45 times 1 times 1 times 180 is equal to 8,100. On the bottom, 22.4. So we got 1 times 22.4 times 6 times 1 is going to be equal to 134.4. Do the division. 8,100 divided by 134.4 gives us 60.3, I'm going to call it 60.3 grams of C6H12O6. So that's how you do that. Hopefully this helps with your stoichiometry. The layout is always exactly the same. It should get repetitive for you. I actually also have handouts with just this layout in it for you. So hopefully, if you can use that, that will also help you going forward. So let me go back to here.